Welcome back, guys. In the last video, we have already discussed about the theoretical part of DP. We have already, talked about tabulation, memorization, and what approach we'll be using. So let's move on to the implementation part. And we are like starting from the very basics. This is a very great question, longest common subsequence, and it's very popular among DP questions. So let's discuss this first, and then we'll talk about the approaches, right? So in this question, they'll give us two strings and we are supposed to return the length of the longest common subsequence. Okay, here we have two strings A, B, C, D, E and ACE. And the things to notice here is that we are supposed to return the longest common subsequence. Subsequence basically, characters that come in that particular order, not substring basically. They are not supposed to be connected, right? Only subsequence. So here we have this a, C, E. ACE is a subsequence that is present in that same order in both the string, and this is like the longest common sequence, subsequence. So see, first comes A, then comes C, and then comes E, and here this order is also persist, right? So that is why we'll return its length. We are only supposed to return its length. So our answer that we should return is like 3. Okay. If we talk about example 2 here, again ABC, they are completely matching, right? So we'll return our answer as 3. Then we have A, B, C, D, E, F, so we return our output 0. Let's take about a little more example. So if we have like A, B, C, D and A, B, D, C, right? So here, yeah, definitely A and B, they match correctly. But yeah, it's up to you. You can even say that ABC might be the answer or ABD might be the answer, because the order of both of these strings that comes in, let's say text 1 and text 2, that's same. Like here we first we encounter A, then we encounter B, and then we encounter C. So that's in string 1, and in string 2 also we first encounter A, then B, and yeah, after some time C. And same thing for ABD, right? We first encounter AB and then D, and then here also we encounter ABD. So both of them can be the answer, and since we're only supposed to return the length, right? So we can return 3 as answer. Okay, I hope this problem is pretty clear. So uh, what let's start with recursion. Okay, let's first start with recursion, because thinking of logic and recursion, it's very easy, and after that we'll try to convert that into sort of tabulation form, so that we don't get a TLE. Okay, let's start. Firstly, let me try to make a, let's say, LCS function that's sort of like a helper function. Okay, uh, I mean, the reason I'm doing this because by making a function of my own, I get a little bit more freedom. So I need like 4 parameters for this particular function. I need m, that is the length of my text1. Okay, I get two strings, text1 and text2, and then I get n, that is the length of text2, right? Great. And now I'll just return the answer that is returned to me by LCS. Okay, now let me pass the strings. So firstly I have my text1, right? And then I have my text2. Okay, and then I have the length of both of these strings. Okay, so we are starting from the very backwards. Okay, and then we'll move to the forward. Okay, I will start from the last character, and then we just keep on matching them. Okay, let's come up with a logic now. Let's say uh, the strings are like this: s1 and s2, shorter to right, and then m and n. M is the length of s1, n is the length of s2, right? So let's now think of the logic. Okay, uh, suppose we have two strings, and in one string we have like 26 characters, and in the second string we have 0 characters. Okay, one string can be like anything, it can be anything, it doesn't matter, but the second string is empty. If that is the case, then what should be the answer? Since we are supposed to print the longest common subsequence, I don't think any character will match, right? So that is why our first condition is, if uh, if one of the string is empty, then what are we supposed to do? If maybe if maybe m, sorry for that, if maybe m is equal to 0, or any of them can be empty. Okay, if any of their length is 0, then I'll just return 0 as my answer. Okay, if any of the string is empty, then the longest common sequence they can get is basically 0, right? So clear with that. Otherwise otherwise, let's say the character matches. Luck by chance, the character matches here. Let's take that same example: A, B, C, D, E and ACE, ACE, right? So we are starting from the very backwards, that I've already told you, right? uh, you can correlate this with memorization. We are like top to down approach. We are moving from the very higher position to the lower, from the very nth index to the zeroth index. So we will start from here and we'll come up here. Okay, so we match this character. We check this characters first. Okay, the last character of this string and the last character of the strings. Now there can be only two conditions, right? Either they match or either they don't. So let's first see that what will happen if the character matches. Sorry, what am I doing? Okay, if the character matches, then what am I supposed to do? So here both the character matches, right? And if it matches, that's great for me. So what I'll do, right now my pointer is here. Okay, let's talk as a in the way of pointers. Right now my pointer, both the strings, it's pointing to E and E. Okay, so if it matches, I should just go back for both of one and I should add one to my answer. One means that yes, there is a character that is common in both, which comes in that same order, right? So I'll just write that S1 and M minus 1, which means the last character at whichever pointing I am. So why M minus 1? Why not M? Because M gives me the length and the indexing start from 0. So you just have to decrement it by 1. So S1 M minus 1 is equal to S2 n minus 1. If that last character to which we are pointing right now, if they matches by any coincidence, then we are supposed to return 1 plus, which means one character matched, great. 1 plus 1 plus, let's call the function again LCS, least common subsequence. Okay, and S1, sorry, longest common subsequence, sorry, S1 S2, and I'll just decrease the length of the pointer of both of them. One, they are pointing here, right? The character matched, I'll just go backward for both of them. So M minus 1 N minus 1, they just don't denote, they just don't show me the length of the strings. They show me at which character I am right now in both of the strings. Okay, because you need, it's not simply a loop. For loop you have like for your I and J, right? But here when you use recursion, you need to, you could have used like I and J again, but that will just increase the complexity without any advantage. So that is why we are just using M and N as a benefit for us. Okay, if you want, you could have just started from 0 0, and you could have moved till up M and N, and you could have actually checked the condition that I is less than M, J is less than N, but that is useless. Okay, so otherwise, okay, we have already checked if one of the string is empty, if and we have already checked if the character matches. But what if the character don't match? What we are supposed to do then? Okay, so if character don't match, then let's say if the characters were like this, A B C D E and A B A C E F. So here both of these characters don't match, right? So what I'll do is I can do two things. Okay, I can either keep the pointer for this, for the first string, right where it was, and I can just move the pointer of the second string one step backward, right? And if I do that, then yes, I think later I'll get a match, right? This That's one thing I can do. Or what else can I do? I can actually move the pointer of my first string backwards, and I can keep the pointer of my second string where it was. So if I do that, then what will my conditions become? Let's think. My condition will become like this: LCS A, sorry, no, S1 S2, right? S1 and S2 string same. Okay, and for one I am moving one step backward, for other I am not. Okay, and what can be the other call that I can make? Let strings same, string will remain same. Okay, and this time I'm not moving backward for the first string, but I'm moving backward for the second string. Okay, and I very cleverly, I'll just call the max function here, max function, because since I am supposed to return the longest common subsequence, then I have called both of these functions, and whichever one of them returns me the largest value, that will be my answer. Okay, so I this is like the complete code, very short, very simple, right? Now let's try to run this and see if it works or not. Yeah, so it runs. Okay, now let's try to submit this if we get a TLE or not. Okay, so we got a TLE, which was expected to happen, right? uh, Now let's see how we can convert this code into tabulation form. This is almost same to memorization. You just have to store the values in some table and you can call that out. So we are not going into that way. Let's try to think of a flaw of the logic for tabulation. uh, Thinking about logic for recursion, it was very easy, right? It wasn't that hard. We just thought of a few possibilities and we just coded it out. But now let's talk about the LCS tab part. Okay, I'll again pass on the same parameters S1 S2 and my M and N. Okay, so now let's start with the coding part. I need a table, let's call it DP. Okay, here I just need to make a 2D, let's say 2D table. two-dimensional table. Okay, and I just need to create. Initially all of them will have a size of like 0. 0 means that basically the longest common subsequence encountered till now is 0. Okay, so now let's try to code it out. I am just making a table right now. Okay, for I in range of n plus 1, and for this in range of n plus 1. Okay, now we have a table. Now let's start with the coding. So I need to iterate. Okay, just now the question arises, how many loops should I use? And the answer for that always lies in the parameters that you have used in your recursion. In recursion, think of how many parameters there were which were changing. So I think there were only two parameters that were changing, m and n, right? uh, we started from m and n, and we moved out to 0 0, right? So I will need two nested loop. Okay, for I in range of m plus 1. Okay, and for j in range of n plus 1. Here this was like what, bottom to down approach, and this is like top to up approach basically. Sorry, this is like bottom up approach, and that was like top down approach. Okay, so yeah, that is the same part. Now let's try to think of what happened. Okay, so now your m is equal to I. Okay, because your I is moving for your m, and your j is equal to n. Okay, so just write this same line of code, but replace your m with I and n with j. Okay, so what was the first line? Let me just copy it. So if, why am I getting this? Okay, there's some error. Okay, yeah, so if m is equal to 0, m means I. If I is equal to 0, or j is equal to 0, I was returning 0, right? So here what will I do? I just dp I and dp j, it is equal to 0. That is like the same line of code. Returning 0 means the putting the value of that particular element for those parameters. Okay, otherwise what were my code? Let me just copy them again here. Else if s1, yeah, s1 and s2 are they'll remain same, but here m will become what? M will become I, n will become j, right? And here I was doing this, right? I was doing 1 plus LCS. So this is like putting the value. So dp, because at the end of the day you are just supposed to calculate the value. So dpi of j will be 1 plus dp of what? M means I minus 1, n means sorry, m means I, n means j. So I minus 1 and j minus 1, right? So just put that. Don't think of what is happening in the table, just copy those whole code lines. Okay, we have written the same thing that was there, right? Otherwise what we are supposed to do? Else dp of I and j. Return means dp of I and j, because this is where you're storing your value. Okay, otherwise you are supposed to return max of what? M minus 1 and m n minus 1 m minus so it will become like uh, dp of m minus 1 n. M minus 1 n means I minus 1 j, or dp of m n minus 1. This m becomes I, and this n becomes j, so it becomes I, sorry for that, and this becomes I, and this becomes j minus 1, right? And once you just you are done with this. Once you are done, once your iteration is complete, just return what? Dpm and dpn, and that is your complete answer. Very simple, right? So let's now try to call this lcs tab. Okay, sorry. Let's now try to call this txt1, txt2. Okay, uh, anything else? No change required. Let's try to run our code now. Okay, so it got accepted. Now let's try to submit this. Where our recursive call failed. There we got a TLE, right? Now let's see if we get a TLE or not. And luckily we don't get any TLE. So this is the power of DP, right? And the codes, what we did was very simple. We just thought the logic in recursive form. Very simple. We just check that one of the string is empty or not. That's completely up to you. And after that, if the character matches, you just add one, and you moved your pointer one step backward for both. And if they don't match, then what you do? You basically uh, you change your pointer for both of them once and once. And after that, we just uh, made converted that recursive code into tabulation form, and that was really simple, right? uh, if you want to find out what should be the dimensions of your table, if you want to find out how many nested loops you should use, then that is done in the accordance of the number of parameters that are changing in your recursive call, right? And that's exactly what we did. After that, I actually just copied the whole codes and I replaced M to I, N to J. Okay, so that's all. And I hope it's clear to you. If you have any doubt, feel free to ask in the comment section. And thank you.